Hello everyone, welcome to this cast. Today we are going to talk about Taiwan's efforts to achieve net zero emission target in 2050. Let's take a look at the country around the world that are trying to achieve a net zero emission target in the future. For example, there are 140 countries with net zero emission targets, which cover about 88% of global emissions. For example, China's cover about 28%, United States cover about 14%, and the European Union cover 8% of global emissions. These countries are major sources of global emissions, and they have set up their target for the net zero emissions in the future. Taiwan also set up its target to achieve the net zero emissions in 2050. For example, we treat the 2005 emission as the benchmark, which is about 268 million tons of CO2 emissions. We expect to reduce the emission in 2025 by 10% compared to that level in 2005. Moreover, we will further reduce in 2030 and we will achieve the net emission target in 2050. So we have proposed the target and we're trying to do our efforts to achieve these targets in the future. Let's take a look at the greenhouse gas emissions in Taiwan. The energy sectors, which cover about 71% of total greenhouse gas emissions, is the major source of GHG emissions in Taiwan. Among these emissions, the electricity covers about 50% of total GHG emissions. Therefore, if we can decompose the electricity, we can achieve the net zero emission target more easily. The other sectors include industrial sectors, which cover about 13% of total greenhouse gas emissions. The transport is also a major source of greenhouse gas emissions, which is also about 13%. The other sectors include agriculture, service, and the residential sectors. In order to achieve the net zero emission target in the future, the Taiwanese government has proposed several projects in order to achieve the net zero emission target in the future. For example, the total budget will be $30 billion by 2030. On the left-hand side, we can see the budget sources. The state-owned company will provide $15 billion, which is a major source of budgets. The new plans, which were proposed by the governments, which are about $11 billion, and the existing plans, which will continue in the future, is $4 billion. On the right-hand side, we can see the project fields, which includes renewables, which will cover the 40% of the total budgets. And the power supply system will also receive a large share of fundings. The energy saving was about 14%. The green transport was about 19%. The other includes circulations, carbon sink, net zero living, and this will be major project fields for the futures. The Taiwanese government also sets its official targets for 2050s. This was evaluated by Taiwan Times Model, which was developed by Industrial Technology Research Institutes. We have benchmark data, which is 2019. We have emissions from non-electricity, which includes industrial sectors, commercial sectors, residential sectors, and the transportation sector, etc. The major sources come from the electricity sectors here, which is 139 million tons. We also have a common sense. In 2050s, with the demand-side policy, we can greatly reduce the non-electricity emissions. Moreover, we introduce hydrogens and bioenergy here. The key point is that we try to electrifications, which means that the emission from electricity is zero here. For renewable, we have 60 to 70% of power supply mix, and hydrogens, which cover about 9 to 12% of power supply mix. gas and CCUS, which is about 20 to 27% of electricity supply here. However, we have a limitation from Taiwan tax model because they do not consider the electricity price adjustments. They don't consider the industrial activity adjustments, and they don't review the carbon price information so far. So we have a limitation from their analysis here. Let's take a look at the relationship between Taiwan's electricity demands and the GDP growth. The blue line indicates the Taiwan GDP growth, while the dashed line indicates the electricity demand growth. We can see that the correlation coefficient is 0.92, which means that these two variables are closely related. So when economic activity change, and will affect the electricity demands. For example, in 2009, we have a negative GDP growth due to the U.S. financial crisis, so with the electricity demand dropped by a large extent in the same year. In the case of a higher electricity price, we have a lower economic activity, which will reduce the electricity demands. Countries around the world has launched carbon pricing systems. The key facts in 2023 is that we have 73 carbon price systems, which cover 39 nations. And this system covers about 23% of global GHG emissions. First, let's take a look at the blue area, which indicates the carbon tax, which means that the government has set the tax rate per unit of emissions, such as US dollar per ton. We have Canada, with Central America and Argentina and European countries. This country has set out the carbon tax systems. The second one is the green area, which is called emission trading systems, ETS, which means that one can buy and sell permits to emit a certain amount of greenhouse gas. For example, we have China, the European countries, Canada, and California. This area has launched ETS systems. Moreover, we have a hybrid system, which means this country launch ETS and carbon tax jointly. In order to understand the concept of carbon pricing system, we introduce supply and demand curve for commodities. On the left-hand side, we have a supply curve. The vertical axis denotes the price, or horizontal axis denotes the quantities. As the price go up, a firm is willing to supply more quantities, so we have a positive slope between price and the quantity for supply curve. On the right-hand side, we have demand curve. When the price go up, the consumer will demand less because they have to pay higher prices, so we have a negative slope for the demand curve on the right-hand side. In market equilibrium, the supply curve and the demand curve determine the P star and the Q star, which is the price and the quantity that the consumers are willing to buy, and the firms are willing to supply in this market. In this case, we assume that the government imposes the carbon tax on the supply curve, so the firm is willing to sell the output at higher prices because the firms has facing higher tax rates, so given the quantity, the firm is willing to sell it at higher prices. Otherwise, you suffer some losses and leave the market. So the supply curve shift up to a higher level from the solid line to the dashed line here. Because the supply curve has shifted up to the dashed line, and the new equilibrium level could be P prime and Q prime. This means that the quantity Q prime is lower than the Q star, the original equilibrium. Therefore, by imposing the carbon tax on the supply curve, we have a lower economic activity, and therefore we have a lower carbon emissions. Let's take a look at the concept of carbon trading system. The key point is that the government will distribute the carbon emissions. The market will determine the price. For example, the government set out the emission permits as the a gray line here. Front end, which is dirty, and he has incentive to emit more. So he will demand for the permit from the market, carbon market here. On the right hand side, front B is clean, and he has low emissions, and he can sell a permit to the markets with the buyer and the seller, and we can determine the carbon price. So this is the key point for the carbon trading system. Here are our conclusions. First, we have shown that countries around the world have set out their target for the net zero emissions. Therefore, Taiwan must commit to the net zero targets. Second, Taiwanese government have launched multiple measures for these targets. Third, we show that carbon pricing is a powerful measure to reduce carbon emissions. That's what I'm going to talk about today. Thank you.